Let's go to question number 333, house number 3. This is medium question. Let's get into it. This is the final question of house number series, and then it also has a lot of sub. So please check it, this question. Okay. The thief has found himself a new place. Wow, he still survived. For his thievery again, there is only one entrance to this area called the root. Beside the root, each house has one and only one parent house. After tour, the smart thief, wow, he knows the binary tree. Realize that all house in this place forms a binary tree. It will automatically contact the police if two direct linked houses were broken into one the same night. Determine the maximum amount of money of thieves can rob tonight without alerting the police. Okay, let's brainstorming. Do you remember the house robber part 1? Part 1 is house is in the line, right? It's in the street. So this is the line, and then second is the rounded, right? So first then end is connected, and then now this is finally it is a tree, binary tree. How you wanna do that? Okay, today I also use greedy as the same as previous. So in this time, I will do the DFS traversal, tree traversal, and then I will use the bottom-up approach. So first, and then I will use the each one I arrived, I will return the tuple. First is rob sum, and then another is not rob sum. So in this case, rob is 3, right? So 3, 0, and then this one is 1, 0. This one is not robbed, this one is robbed. So in this time, I will check if this one is robbed, this one cannot rob. So I will compare which one is bigger. And then if this one robbed and then this one is robbed, so sum is 2 and then 3. So this one is 3. So robbed is the 2 and then unrobbed is 3. The same, robbed is 3 plus 0, so 3, and then unrobbed is 1. So next, in the 3, and then also check 3 with unrobbed is 3, right? So this is a 6, and then this unrobbed is 1, so 7. 7 is robbed, and then unrobbed is 2, 3 is 5. So I gonna return 7. Does this make sense? Yeah, that's right. So in this time is okay. Sometimes we need to consider this case 7, 1, 2, 9. At this time we need to choose this one, right? So let me explain this one while implementation code. Okay. First I need to the function, the DFS traversal, and then receive argument as node. So if not node, that means we are here. First is here, right? At that time, I will return which number? That's right, 0, 0. So first is rob, and then second rob and not rob. This is sum, right? It also sum. So to the bottom-up approach, I will do left bottom side, right? To do that, left is DFS node left, then right is DFS node right, and then each of them is the tuple, right? So okay, let's calculate the log sum. Log sum is node value itself, and then plus the left dot lob and the right lob, right? So left right lob is the 0, 1. So this is 1 plus right also 1, and then not lob is left 0 plus right 0. Is this okay? I think that sometime okay and sometime not. So okay, let's think that this case, if 3 is 5, 1, 1, 6, at this time we needed to choose this one and this one. So at this time, one of them, this one is not 0, right? So because log, not log, 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 right? So that is the reason why we needed to the maximum value. Does this make sense? And then we come log and not log. Okay, finally I will get maximum DFS node because it return tuple. So this is root. Okay, let's check the code. Okay, looks good. Okay, cool. Okay, let's check the complexity. Time complexity is if the n is the number of node, it is linear time because it only touch one by one. And then space complexity is height of tree, right? And because we use the system stack while recursion, right? And then worst case, the height of tree, if the tree is the left side screwed or right side screwed, height is same as the number of node. So we can say it take linear time with linear space. Thank you.